Hello and welcome back to Inside the Dojo Unreal Experiences here at Virtual Production Dojo. My name is Jesse Segal and I'm your host. And today's session is all about performance, precision, and real-time reliability. The invisible work that makes virtual production actually function when you're on set. Our guest today is Mfon Enoh, an Unreal Authorized Instructor, a game developer, and a powerful advocate for inclusive innovation across Africa and beyond. With over 15 years of teaching experience, Mfon has built a reputation for translating complex Unreal Engine systems into practical, production-ready workflows that empower creators, educators, and studios alike. In this session today, he is going to break down real-time optimization for virtual production in Unreal Engine, from Nanite and LODs to lighting cost, draw calls, and the performance pitfalls that can derail any ICVFX work, LED wall work, or real-time virtual production and light playback. If you want your scenes to run as good as they look, you're in the right place. So let's get started, and please welcome Mfon Enoh. The subject that you're going to speak about today often catches a lot of people when they're
Yeah,
not
because
ready.
performance is very important.
Absolutely. So can you tell us a little bit about the reason why optimization is important, especially when it comes to real-time playback and virtual production in general?
Yes, one is the size. It's important because every time you want to run a project, you have a particular size in mind. And sometimes where you want to host the project, there's a size specification. You have to work within budget. That's one. And then the other one is performance. You need to consider the features of your camera. The camera needs to run smoothly. And those also watching, your viewers, need to enjoy it, what they are watching. And that's why performance is very, very important for smooth transition of virtual production.
Indeed. Now, most people working in Unreal Engine, it makes life so much easier. You can just drag and drop and you can see all this beautiful visual scenery come to life. But does putting let's say, a rock in the scene make it heavy, or is Nanite going to help optimize it? Now, that is something that a lot of people don't understand it.
Yeah, I'll be talking about a lot of that. Sometimes creators go straight to Fab or other DCC and they bring in assets, which is good. But sometimes when these assets come in, they come in very heavy.
Mhm.
Optimization will enable you to know what tools to use to minimize the size. And that's exactly what we are talking about today, how to reduce the sizes of assets on your level so your game and your cinematics run smoothly.
Well, for one, I can't wait. There's always room to learn more. So, with that, the floor is all yours.
Thank you so much. Thank you. You open your Unreal Engine scene, everything looks beautiful, detailed, and cinematic. But the moment you move your camera, you begin to struggle. The frame rate drops and Unreal may crash mid-take. This is where real-time optimization matters. My name is Mfon Enoh, and in this session, we'll be discussing real-time optimization for cinematic workflows in Unreal Engine 5. I'm an authorized instructor. I build games, and I also have games on Fortnite. We'll take this step by step, slowly and deliberately, to understand how Unreal Engine actually spends performance and how to optimize without sacrificing visual content. By the end of today's session, you'll be able to explain what optimization in real-time cinematic workflows means you make informed optimization decisions based on camera requirements. You profile a scene using Unreal Engine performance tools. You apply basic optimization techniques and then verify performance improvement using measurable data. What is optimization? In virtual production, optimization is the process of ensuring scenes run smoothly and consistently while maintaining the visual quality required for filming. In Unreal Engine, optimization for virtual production means maintaining stable frame time for real-time camera tracking and playback, ensuring performance remains consistent while the camera moves, the lighting changes, or the environment stream in. Why do we have to optimize? We optimize because real-time projects have fixed performance budgets. Cinematic scenes still run in real time. Unoptimized scenes will break when the camera moves, the world streams, lighting changes, and assets scale up. If you don't optimize early, you pay later with interest. The common areas to optimize are the engine configuration and project setting, lighting, world streaming, quad overdraw, and level of details. We also have draw calls, textures, size maps, and others. Before optimizing anything, we listen to the engine. Let's get started as we open the project for this session. This is
well, I have my project open, and we will be sharing the project that you have kindly provided for the participants when the recording is published on Virtual Production Dojo as well.
Okay, thank you very much. And I encourage everyone that's joined this session to please open up your Unreal Engine, and it's a follow-up class. We're doing this, it's a real-time class. I want us all to join and then open up projects and practice. So first we want to check the frame rate. How do we check frame rate? You press the tilde key on your screen, on your keyboard, or on the console command here, type in start FPS, and you hit enter. So once you do that, you see the frame rate on your screen. On the top right, mine is about 8-9 FPS now, which is very low. Now, there are other few useful commands, console commands we are going to use throughout this session. The first one is start units. Now, when you see that to the right, you also see the frame time. Currently, this frame time is about 130, 126. You see the game time, 81 milliseconds. You see draw time, you see the RHI time, and the GPU time. Also, we have start units graph. And to the bottom left, you see a graph. So start unit time gives us the graphical representation of what we have in the start unit. And the other one is start GPU. And then I have it there. If you look to the top right, you see the frame time is about 120-something milliseconds, and the GPU time is 19 milliseconds. Now, this particular table, the start graph, tells us, start GPU, tells us how the GPU time is spent. Firstly, I'm going to clear all of this from my screen. How do I do that? You use your arrow key, up arrow key, and you repeat the command. I'm just going to hit this and it takes that off. I'll do that again using my arrow key. That's repeating the command and pressing enter takes off that from your screen. We need to take up this as well. And with that, we have all of them taken out of the screen. Now, back to the start GPU. I have some explanation there, so I'm going to bring that. That's the only thing I want to have on my screen now. Start GPU, and I hit enter. Now, if you look just beneath the Q total here, you see the rendered deferred lighting. So the deferred lighting, you see how many milliseconds is spent on average, minimum and maximum. Minimum, on average, I have about 10 milliseconds. And then just beneath that, you see lights. You see what is spent on post-processing. You go down, you see for volumetric cloud, and you can have all of them telling you how the GPU time is spent in real time. So the GPU is half of the story. We also have the CPU. How do we profile what is happening in the CPU? I'm going to take this out before I bring up the command for good. Now I'm going to use start RHI. I hit enter and I have it here. Oh, no, that's the wrong command, start game. I'm meant to use start game to see what is going on in the CPU. Yes, this is for the CPU. We see all that is happening in the CPU. Just beneath here, we have the tick time. The very first row, you have the tick time, how many call counts, and how much time is spent in the tick time. The CPU and the GPU, they are like the engine or what processes, what is actually going on in Unreal Engine and in our level. I'm going to take this out as well, start game. Now, the start game shows how the CPU is spending time each frame. We have seen everything that went through. We have seen the tick time. The tick time I had was about 10 milliseconds. And tick time represents how much time the engine is spending updating actors, updating components, and gameplay logic every frame. That's what the GPU time, the tick time tells us. And then another useful command is the start RHI. Start RHI. Now, why this is important is we'll be speaking about draw calls today, so we need to see how to actually know how many counts our draw call has gotten. Now, beneath here, you see the counts for draw call. Oh, I have to go into full screen for us to see that. Okay, now this is it. Okay, just beneath here, you see draw call, draw primitive calls. Currently, I have about 614 counts. That's what I have here, about 614 counts for my draw call. We have talked about start RHL, start unit graph, which shows us the graphical information at the bottom left corner of the screen. We have also seen start units and start FPS, which gives us our frame rates. Now I'm going to take this out of my screen first by going back to the default and using my arrow in the console. Oh, yep, and then I'll say that. I want to talk a bit about what is called thermal throttling. Within the week, my system suddenly became very hot, and I had to work. I was using Unreal Engine. I noticed that the FPS became very, very low, even when the GPU wasn't busy. What was happening? What was happening is called thermal throttling. The laptop was getting hot, so the CPU automatically slowed itself down to protect the hardware. So sometimes, apart from performance, people also want to check your hardware. I saw that the FPS was really low, things were, and then the system was hot. So at that point, what happened is called thermal throttling. When the system is not functioning the way it should, the CPU tries to control and then reduces the activities on its own. Now, once cooling is improved, performance began to pick up. I had to turn on, I got another fan. What happened was the fan of my system had some issues. I didn't know it had stopped working. As soon as I got in another fan for the system at the base, the cooling improved and performance increased significantly, even without changing anything on my screen. And so this is why optimization results can vary from one machine to another. Optimization results vary from one machine to another. And so sometimes poor performance isn't only bad optimization. It's the hardware slowing itself down to stay safe. At this point, we have observed, we have measured, and we have listened to the engine without touching a single setting. This gives us a solid foundation as we get started. Before we take further steps into optimization, the engine itself must be configured. We must configure the engine for stability, for safety, memory safety, and for long session open world work. And so that will lead us to the next subtopic. We'll talk about project settings and configuration. We're going to configure our engine right now. From the edit menu, click the edit menu and move your cursor to project setting. This is where we enable or disable engine level features such as forward renderer, ray tracing, global illumination, and many other rendering systems. A quick note, changes made in the project setting require a restart of your engine in order to take effect. So when you make changes, in the project setting, always restart the editor. Sometimes you get a prompt you actually get a prompt from Unreal to restart. Say yes and restart so it can take effect. Now, let's talk about ray tracing. One thing that has a very high cost on RTX system is ray tracing, especially and other lighting related features. Ray tracing itself is not the problem, but when it is not controlled, it becomes a problem. Now, if I search here, ray tracing, and I hit, and it comes up. Now, look at, if you go through, now that I've searched ray tracing, if you go through the whole of this, you can see all the individual controls we have for ray tracing. Most of them are enabled by default. For example, we have use hardware ray tracing when available, and we have that tick by default. We have ray trace shadow somewhere here for shadows. And then we also have support hardware, look at it, support hardware ray tracing. All of these features and each of these options, they add cost. Not every project needs all of them to be enabled. So you have to decide, you have to find out, what am I really doing? What do I want? Do I need all of this enabled? Now, that's one. The other one is you can actually edit project settings via your config files. I'm going to I will open up the project folder, and there's a folder inside of it called config. I'll open it up and open the file called default engine.ini. Okay, some of them will have .ini. If I right-click on this, select it and right-click on this, you have the option to open it using, you have here open with. So you can open with Notepad or Visual Studio, any of them you can. So I'll just pick one. You can also have the option of Notepad++. Yeah, you have that there. I'll just select this and make a little explanation. Why this is not okay? It's coming up. One very important section here is the rendering section. The rendering section here, this, okay, close that. This rendering section, you can see we have ray tracing true on by default. This section is very important because it has a direct impact on the GPU performance. So you will notice that some of these features, some of them, including the ray tracing option, they may be enabled by default. But if you do not need to enable this by default, you can edit this. You can edit this and save. And then even for the ray tracing, you can bring in codes. This ray tracing, you see, some features may not be needed. If we don't need certain ray tracing features, we can disable them. This way, we remove unnecessary GPU costs from even before the editor starts running. So we can use this. Then we can also look at path, scroll down. Here we can also add the feature to enable path tracing. It also applies to path tracing and even lumen. If you are not rendering cinematic shots, path tracing should be disabled at project level. And that's that. I'll close this folder. Next, we'll talk about mega lights. Back to edit menu, project setting. If you are using an RTX GPU, I strongly recommend you enable mega lights. This feature significantly reduces light complexity and improves performance in scenes with many lights. There are scenes that require many lights, and maybe optimizing may be difficult, but mega light helps to reduce light complexity. You search here, mega lights. Mega lights. Okay, so you see that is it. You can actually visualize the difference if by checking the light complexity, which we'll do very soon. The light complexity view modes. But I am using a GTX, and even if I enable this, feature, I'm going to have an on-screen message. This on-screen message says mega light is enabled but has no ray tracing data. That's because for GPUs, mega light is disabled, which is why I don't, even when I tried enabling it, it still gives me this on-screen message. So you enable mega light only if you're using RTS hardware. Mega light requires full inline hardware ray tracing, which isn't available on all platforms. And so if you will go further to talk about optimizing light, just for the sake of those of you using GTX. So I'm going to take that out. Okay, and so just by tweaking, yeah, I'm going to have this. Taking out, because it won't work for this system. So the hardware that really that is compatible with mega light is the RTX. We'll come to light mode and then move your cursor to optimization view mode, and we have light complexity. So look at this scene. Enabling mega light. Let me just explain so you see the effect. Enabling mega light on this level, on the editor in this case, will help us automatically control all of this white light you're seeing. As you can see from this strip here, the blue is good. The green, from green up, you have is bad, and the white purple section is extremely bad for the scene. That's how to use light complexity to test. So before enabling mega light, please do this and see the difference after you enable that. So I'll go back to lit mode. And so just by tweaking project setting, even without touching anything, any assets, we can actually gain stability just by configuration of the engine, proper engine configuration and project setting. Next, we're going to look at is, I just have to follow up. Next, we're going to look at virtual texturing. I'll open up my, okay.
Mfon, if I can ask a quick question here regarding the lights. Now, of course, inside Unreal Engine, a lot of game designers, as well as environmental designers for virtual production, what they tend to do is they put a lot of lights. As you just mentioned, that adds a significant demand on your system, on your project, GPU, and so forth, right? Now, is there a recommended number of lights they should have in a project? Because I remember doing a project where there were over 450 lights, and Unreal Engine just went down, and when I got it from the team, I had to spend a lot of time in optimization and rebuilding everything else.
Thank you so much for that question. In as much as we do not have a recommended number of lights for a scene or for your projects, what you can do is budget. What are we building? What do we need? If we really need a lot of lights, there are optimization tools that you can use. Like Mega Lights can help you bring down a lot. So if you're on RCX hardware, Mega Lights will help you a whole lot. And the other one, you can fake lights. That's we're getting there. I don't want to be too fast. You can fake lights on your scene. You can use emissive and then opaque material, and then you can fake lights. And very important in virtual production is so for you to, your light is for your camera, not for the entire room. So you ensure that lighting is within the area that the camera requires. Others can be disabled. And then we're also going to talk about world streaming, where the engine only focuses on the area, the particular area where the camera is facing. Well, back to what I was saying, virtual texturing. Thank you so much for that, Jesse. Thank you. Virtual texturing. Now, back to this edit project setting. I think I click, oh yes, I did click. So under the rendering section of the project setting, there are two options I want to highlight. Rendering, yes, this is it. Now under this, there are two options I like to highlight. That's because they have direct effect on performance, memory, and how imported content behave. And that's the first one, is virtual texturing. Virtual texturing helps us to manage large worlds and high resolution textures more efficiently. And so to enable it, you scroll through and see virtual texture support. I usually like to type this in for a very quick one, but let's scroll down and see. Okay, so I have it here. Look at that. Enable virtual texture support. And then there are two types. I'll talk quickly about these two types: the runtime virtual textures and the streaming virtual textures. Now, runtime virtual textures are ideal for landscapes, procedurally generated content, materials that are baked into virtual textures, and it also improves performance. Virtual texture improves performance. It uses more memory. So you have to take note that it uses more memory. It also helps materials that are baked into virtual textures. The other one is the streaming virtual textures. This is ideal for large, high detail textures. It reduces memory usage, and it's slightly higher in terms of runtime cost. It has a higher runtime cost. And so, enabling this virtual texture support, you restart your engine. I have mine enabled by default, so I don't need to restart. You restart your engine. And when you restart your engine, the next step is to go to your content browser. Move to the content browser, select, let me use, for instance, texture. I'll just take any texture here, I'll select this one, and I'll right-click. I'll right-click and I'll say, convert to virtual texture. So this takes some time and convert this to virtual textures for us. And so runtime, I'll just say on OK. So runtime virtual textures are best when we want to, for content that are generated dynamically and content that needs to be baked for performance. We need to use a runtime virtual texture. For instance, landscape. And then the other one, the streaming virtual textures, is better when you are dealing with large textures that need to be streamed efficiently. So for real-time gameplay, runtime virtual texture is a better choice. For cinematic and virtual production, what we need is the streaming virtual texture. This makes more sense when you use that. Now, we quickly also look at shadows and lumen. That's the other thing I want to talk about. In the edit menu, we'll look at lumen. I'm just waiting for this to be done. We'll look at lumen. In between, I hope we are all trying out what we're doing this together. I hope you're also practicing this with me. You're seeing how it works real time. Jesse, are you doing that with me?
Yes, I am.
Thank you.
There's always more to learn.
Thank you.
Now, while that we are waiting for the process to complete for the virtual texture, now, one thing as an educator, when I'm teaching graduate programs as for virtual production, a lot of candidates, even industry professionals that we train here, what we find is they simply bring the asset, like you mentioned, from Fab or any other marketplace, and they do not think about the virtual textures, right? And it is usually optimization becomes an afterthought, which is the trap that a lot of productions fall into, right? So they finish the entire project, they put it up on the LED wall, and then they hit play or they, stream it, and everything is moving very slowly because the frame rates drop. So does every asset that we are putting into our scene or we have imported, is it a good practice to convert those into virtual texture when we are importing it? Same as with Nanite, which obviously you'll be talking about.
Yes. Thank you very much for that. Optimization is an ongoing process. You need to carry out optimization in your project at the beginning, at the middle, and at the end of your production. Some mistakes made is that creators just keep, building, designing, creating, and forget to optimize. And they leave it to the end of the production. And then that's when it becomes like a burden on them. Just like you said, as you're bringing in the asset, check the size. Is this something within the budget of my project? If it's too large already, what do? As you bring it in, work on the asset first and minimize and optimize it, even while the project is going on. Do not wait till the end of your project or production before you optimize. Let me stop sharing so that this, I think it's stuck somewhere there. I need to stop sharing, or my camera is stuck there, and that's why sometimes I have ready-made ones already, so I just show so that Unreal Engine does not act up. I have stopped sharing. Maybe I take off my camera just 1 minute so that can be done and we can go up. Thank you so much, Jesse, for that question, for that.
Absolutely.
Okay, so let me see the projects, how far that is going. Okay, I think it was that was the problem. It's fine now, it's just done. So I can turn on my camera and I can share. So we got the trick now. Okay. Please let me know if you can see my screen. Oh, that was not almost. Okay. Can you see my screen, please?
Yes, we can.
Okay. So in the edit, from the edit menu, project setting, let's talk about shadows and lumen. By default, virtual shadow maps are enabled. I'll scroll down to see that virtual, to just confirm that. Okay, rendering section. That was my bad. I needed to be at the rendering section. Yes, and I'll just type in virtual tab. I'm used to that, virtual. Okay, so you see that shadow map method, we have it here by default, virtual shadow map. And by default, this is enabled. If yours is not, this is what is selected. Now, this is the recommended setting, the recommended shadowing method in Unreal Engine 5. Virtual shadow maps provide higher shadow resolution, better integration with Nanite, and compatibility with world partition. And it's also a proper support for lumen. Next, I'll look at is the lumen configuration. I'll just type in lumen because I don't want to go looking for that. In the lumen section of the project setting, you see all of the things that we can control. You see the reflection method, lumen. You see the reflection capture resolution. We can control all of this in this setting. And then we see software ray tracing mode. The software ray tracing mode is global tracing. These settings are the recommended settings to enable your map or your level, your scene run smoothly. However, depending on the project you are working on, you can control the lumen setting from the project setting. Now, so far, we have focused on project setting. Next, we are going to go forward to convert this map to world partition.
Before we get on to that, I think one thing we need to tell all our viewers is the project settings is only limited to the project that you're working in. It is not engine-wide. So the project that we create and we are designing our worlds inside, the project setting is only limited to that. And is there a way that we can copy those project settings to other new projects as well?
Yes, you can actually look at the previous setting you used. If it's okay, you can then use that setting for your next project. Just like Jesse mentioned, this is not industry standard. The project setting depends on what the project you are working on. Is it game you're developing? Is it cinematic? Is it are you working on TV production, media, virtual production generally? So your project is the kind of project you are creating will determine what setting you require. I think I also mentioned it when I was talking when I was explaining the default engine.ini. So sometimes you have ray tracing, but you don't need all of the features of ray tracing. You can go to the default configuration and then change the settings to suit what you want to do. Okay. Next, we're going to talk about. Okay. I think we'll go back to lighting. I need to talk about lighting quickly. Yes, I was about to mix this up. So in virtual production, lighting isn't just about mood. It's about whether your scene can stay stable for the entire take. And so we use light complexity to judge this a lot. And so light complexity shows how many lights are affecting each pixel on the screen. The more lights that hit the same area, the more work the GPU has to do at every single frame. So when we switch on to the light complexity mode, we can see different colors. I'll move back to the engine and see that now. From the lit mode, let's move to optimization view mode and light complexity. These colors tell us how expensive the lighting is. Blue is very cheap. One light it's well optimized lighting in that area. Green is acceptable, but not the best. And then we have from orange, yellow is expensive. White is very expensive. We probably have too many overlapping lights in that area, and we'll look at it now. Now, I'll select just one of these. This is a point light. You see from the details panel here. And then you see, okay, in the outliner, you see that's a point light. And then you see there are so many point lights placed on this level. Why? Is there something we can do to make this better for us? Point lights can cause problems. Point lights emit light in different directions, like a sphere in 360 degrees. So when you place point lights close together, like you see, these ones are very close, and so they overlap. Their influence overlap, and then overlapping pixels get multiple times and giving your system so much work to do. And we'll actually see this in your scene, in the corridors, your interiors, and light bulbs. Point lights are used for light bulbs, decorative lights, and all of that. Therefore, what is the fix for this? Reduce light overlap as much as possible. You see, when I let me delete this point light, you begin to see the effect. I delete another. If you notice, there are changes. Let me delete another one. There are changes. I'll just take them out one by one for you to see the effect. See how expensive point lights can be. Now I'm taking them off. The other thing you can do is you can reduce the attenuation radius for point lights. That's a way of optimizing that if you really need it on your level. And then if two lights strike the same surface, it's going to cost us. The cost will keep stacking and stacking and all of that. Also, avoid intersection. Unless it is absolutely necessary, you have to avoid light intersection. One light per area is okay instead of many, many lights in that particular area. The other one is to replace spotlight with point light with spotlight. We'll demonstrate that just now. Now I have this one. I want to delete this. You see that light was everywhere around it because it's like a sphere. It emits 360 degrees. Let's bring in spotlight and see how it goes. From place actor, I have light here and I have my spotlight. I'm going to drag this in. Let me drag it to this scene. And so look at spotlight. I'm going to take this up a bit. That's spotlight. See the difference? So what does spotlight do? Spotlight will just focus on the area you want. Maybe for the camera, it's going to focus on one area. It's controlled, so it's cheaper. Point light is 360-degree emission. It's more expensive for us. Spotlight just focus on a particular thing. And you can even control the level of focus. It's controlled. So now that we have converted, you see immediately light complexity improves. If we change all of this on our level to spotlight, you see it's going to, I can bring in another spotlight there. And then you see that is going to improve performance like that. Now we no longer have white in that region. We can then control it actually. The other thing is to disable shadows as much as possible. I'll show you how to do that. I'm going to bring back one of those point lights I deleted. Yes. Selected in the outliner, move to the details panel and type in cast shadow here. So look at it, cast shadows. You can disable this. This also helps optimize to an extent. So you disable cast shadows. What else do you need to fix? Use small practical light, few light. You can use spotlight to replace your point light. I mentioned that. Turn off cast shadows and then use small lights. Don't try to light up the entire area. I also mentioned that you can control the attenuation radius. So that's it. The light will still illuminate the scene. It just will not generate shadows. And so it's going to help us a lot. The other fix is to use pure light and then fake the rest. Add few lights to your scene and then fake the rest. In real time and in virtual production, we light for the camera, not for the room. And so the techniques for faking light, you can use emissive materials for bulbs. And then you can use one light and an emissive mesh. You can combine that. That will also help. And then you will let lumen indirect bounce to do the rest. I have mentioned that for RTX system, Mega Light will help you a whole lot. It will help you collapse overlapping lights into a much cheaper lighting solution, thus significantly reducing light complexity. That's it about light. I'll go back to world partition. We'll talk a bit about world partition. World partition is Unreal Engine's system for automatically loading and unloading parts of a large world based on camera position. And so instead of loading the entire level at once, you can load only the area where the camera is using. So I'll take this aspect slow and steady because everything we do here determines how the world is streamed in later. World partition breaks a large level into grids and only streams in the cells the camera actually needs at the moment. So as the camera moves, nearby cells are loaded and the distant cells from behind are actually unloaded automatically once you have done your setting. Why do we need world partition? Why does it matter? Very important. It reduces memory usage. World partition helps a lot in terms of memory. And then it improves stability. It prevents loading massive environments all at once. And then in real-time performance, it makes it more predictable because you can control what is happening. So let's get back to the project and see how we can do that.
So, Mfon, is it better, like you said, and I absolutely agree with you, that the optimization should be something that should be tackled from the beginning of the production, not only at the end, and for people who are starting new in Unreal Engine, this is the perfect thing to learn rather than, hey, how do I just start building beautiful worlds, right? But when we are building for production versus for game, the whole uh, end result is different. Does the optimization patterns change based on what our output is? And also, seeing that you'll be talking and showing us about the world partition, when it comes to streaming for production or making a small game, is world partition something that everyone should start with, or just create a blank level and start from there?
Okay, just like you said, thank you very much. Depending on the size of what you'll be looking at, world partition is becomes very important if we're looking at large worlds. So if what you're doing, if the scene, the level is very large, world partition, I'll say, is very important and it's highly recommended at that point. But if your map, like you see some, like you said, games, some of them are very mini, just maybe 1 or 2 grid size, you may not really need to put in all for your world partition. But for large worlds and big screens, yes, we need to use world partition. And the other one you mentioned earlier, optimizing as your project goes. Yes, I always recommend that. Don't wait till the end because it could get very cumbersome and tiring. So as you start your production, start optimizing. You're bringing in assets, consider that. Do I need this? What can I do? Is there a cheaper version of this? Is there a low dense or low detailed version of this asset? That's what creators should always think about. You want to download assets from Fab or from anywhere, just consider the site. Go check the site. Go check the details. Is this something my engine can take? And those are some of the checks you can do even before you start or while you're creating. So you're welcome. So there are different ways to convert any level to world partition. I'll just check. The other level I was using was not sometimes you open and you try to check if I'll just check that here. Not all maps. Okay, world partition is disabled for this map. Oh, so we have to do that together. You go to tools. There are several ways to convert your project to world partition. If you didn't have that by default, sometimes by default, you have your map having world partition already. And so you just go ahead and get started. Thankfully, this one has none, so we can learn. On the tools menu, you can scroll down and see convert level. You see, this is one way to do it, convert level. But this convert level usually works for small maps. For large maps, for large world, the best way to convert is to select in the outliner. I'll just select any of the actor here and hit Control A. And when you do Control A, everything on this level is selected. Everything, all the actors are selected. And I'll go to Edit and say Copy. It will take some time and then copy that. It will take a moment and copy. Once that is copied, I'll go to my file. Okay, that's still copying. Once it's done copying, you see this will be disabled. This part is important as well. So we want to create world partition. That's what we want to do now. Okay, and that's done. Beautiful. So you go to File, New Level. And we're going to use the empty open world. You select this one and hit Create. I may not even need to save this anymore since I already have. You can choose to save, but I don't want to save since I've already copied everything in it. And I'll be having another map. Now, this is the open world level. What do I do next? I'll go to Edit, and I'll say Paste. I'll paste in all that I did. Copy. This will take a while as well. Just give it a moment. Okay, so I don't think I have it. I think it's still. Okay, I'll just say paste. I'm not sure that first one did work. Because I'm meant to have a dialog box to save. Okay, now it's working. Good. Now, once the paste is complete, this is a good time to save the map. I'm going to save this map. I'll just say save current level as. I'll just say land. Okay, I'll just say world partition. So we remember world partition. And save it in the maps folder. And now this is good. Still taking time to. Okay, this is good. Now I'll go check out take this up and look at the world partition. Okay, so you see now, this is the world partition. This is now enabled. And you see this is divided into streaming cells. You can see this is now divided into streaming cells, just the way we want it. And so, because the open world setting has world partition and enables streaming by ready, you already have this, what do you call it? Enable streaming is ready, set for us. So I can right click this. I can right click and unload this region. You can right click and unload. Now you can control this from here. If I say this and I click unload, it's going to unload everything that we have here. If I also want to stream only a portion of the camera, I can do this and then right click and load from this region. We'll get back to that later.
Mfon, can you just, for our viewers, just show if they don't have the world streaming window, the grid, how do they switch it on?
Okay, yes, I'm going to just let me take them out. If this is not here, I think I forgot to mention. You go to the Windows menu, scroll down, and you have the first one. You will need world setting, but let's also go look at world partition. World partition, and then you get the world partition editor. This will bring it up for us. This will bring up. Thank you so much for that. I think I skipped that part.
Yep.
Now, also, let me select an actor on the level. If I select this actor, and I click the details panel, I can check. I'll just type in here, spatially loaded. I'll bring this up one. Yep, look at that. It's spatially loaded. It is checked already. What does this mean? This means all actors that have this check, it means that these actors participate in the world partition system. That's what this means. Once you have it, all of the actors that have this check and all the actors on this will have this check because we have converted this level to world partition. So now let's go to world setting. We need world setting here. Back to Windows and scroll down and select world setting. Now, in the world setting, let's locate the run. Look at very close here, you have runtime setting. In the runtime grid section, we have what we call runtime partition. Just beneath that, we have runtime partition. And so we have index 1, that's the main partition. And then we have, scrolling down, we have a lot. So we are going to pick this. The very first index I have here, I care about two main things, the cell size and the loading size. Now, let me check. The cell size for this is 12,800 units. And that's about 128 meters. I'll still scroll down to check out the loading range. Now, just beneath it, we have what is called loading range. 25,600. That's 256 meters. This map is not very big. For very big maps or world, open world, it is always very good to have your loading range to be 3 times that of the cell size. Okay, let me do this. Let me check what the default was. Okay, the default here was 25600, and this was also 25600, which is okay for a small world. The loading range and the cell size can be the same for a small map, but for large maps, you need the loading range to be 3 times the cell size. How do I do that? I just put in asterisk 3. And once you hit enter, it's going to give you times 3 of the cell size. This is especially advised for large map. So if your map is very large, ensure the loading range is 3 times as big as that. So, but I'll go back to, I'll reset this just for explanation. The next thing we have to look at is this debug column. Look at this debug column. Now, I also have show grid preview. Once I enable this, it's going to take up this color, and then we can see. Let me move this far left so that we can you can already see what is happening. But let me see. Let's take this top. Let's look at it from top. I want to look at this from top. You see what is happening? We have, not all of them have the debug color. What does it mean? As the camera, it's focusing only on where the camera is focused. So as I'm moving, as the camera is moving, some areas are unloading and loading. If the camera also moves forward, the same thing happens. I just want to have a very good, I want to have a good view. Yes, this is what I want to have. Okay, so to understand what is actually happening on your map, try and enable the show grid preview. Just enable it and it will take this up. A bit more explanation on this. You see the grid. We are saying this, the camera is facing this way, and so the grid cell will load. It loads in, and the surrounding cells are also loaded. Look at the surrounding cells are loaded based on the loading range that was selected. The loading range was the same as the cell size. Now I'll go back and make it 3 times, and let's see if there will be any difference. Now I'm going to say 3x, and I can also reduce it for a small world. You can also reduce your loading range. So I'm going to do Do I do 3x or 2x? Let's just try and see. Oh, look at that. Now that I did 3x, I'm sure you're getting value for this. It has extended the loading range. So for large walls, try to, because for large walls you want to see, you want to have some more, you want the camera to catch up some more land, some more areas or scene. I'm going to close this and take up, I think we're done with that. I'm going to take out the, I'll disable the show grid preview. Yeah, that's good. For small maps, the loading range and the cell size can be the same. So, but for large maps, if you leave this default loading range, it might limit a large map. So adjusting the loading range for large walls is very important. Also, a very good starting point for large maps is to set the loading range to about 3 times the cell size. So I also showed you how to do that. You asterisk 3 to multiply 3 times. And once you do that, you'll be able to see multiple grids being loaded in. Now, let me quickly show you by hitting play. Let me play and explain this a bit more. I'm going to hit full screen. Now, so this is what word partition does. As the camera moves, the word before it, the cells before it will begin to load. While the cells behind it, or the ones that the cameras are not focusing on, they are unloaded from the memory. Thereby, that's a very good optimization, a way to optimize your scene, because now the memory is not overloaded. Using the word partition window, we can manually unload and load. I'm going to go there now. This is it. I can click this and unload selected region. Now, after that, I can pick just a portion, only where we have the camera, right click again, and say load region from selection. Oh, I need to go off. I was playing and then I was doing this. I need to stop the play. Now, good. Then we can just, what we have now is just this region where the camera is located, where the camera is focusing on. So this gives us direct control on how much content is loaded into the RAM at any given time. Word partition helps with memory management and streaming, but it does not automatically optimize mesh complexity. No, it only helps us for memory management and streaming. It does not automatically optimize materials or lighting. So you still need to practically optimize your work on LODs, draw call control, and overdraw management. So next we'll be looking at overdraw, LODs, and draw calls. Each of these mentioned, these 3 mentioned, they have direct effect on how fast Unreal can draw what the camera sees. So next we look at quad overdraw. I'll just try to, yes, we have it here. What is quad overdraw? Let's know what this means. Quad overdraw is when the GPU redraws the same pixels over and over. And this actually happens because of dense meshes, overlapping overlapping transparencies. We'll see that real time. When light overlap, when window glasses overlap, this affects overdraw. So when we'll be looking at blue is LD, green is warning, and white is danger. Back to the project, let's quickly see that. Let's see how that works. We're going to go open up, this is optimization view modes, and then quad overdraw. This is what I need. I just move around to see where, okay, first I go to lit mode. I want to pick where we have assets that will be affected by quad overdraw. Yes, I think this region will be good. I've seen some things there. Optimization view modes, quad overdraw. Now, I'll move close. Also, we have this trick here. Blue is very good. It's LD. And then green is a warning sign. And then we have the purple and white, usually danger. Let's move to this region with purple, white. Purple and white. What is happening here? What assets do we have? Why is it really affecting these ones? Okay, so I'll go to lit mode so we see the assets there. Okay, what do we have? Okay, we have a window here, and so this is a glass material. This is a glass material. These are overlapping glass materials. And then we have fire particles. These are fire particles stacked at a point. Let's go back to quad overdraw mode and see what exactly it is. Now, quick explanation. The GPU doesn't calculate pixels one at a time. It calculates it in groups of 4 called quads. The GPU does not calculate pixels one by one or one at a time. It calculates it in groups of 4 called quad. And so this is called quad. I said that. If any of the triangles intersect any pixel, the GPU will still calculate the other 3. And so it becomes like so much work for the GPU to do. In virtual production scenes, we often have quad overdraw with fire particles, if we have them on our scene, smoke, glass, LED screens, and any translucent material. Also, every overlapping transparent layer adds more overdraw, more job to the GPU. Adding, avoid stacking translucent materials. That's one fix. Just avoid it. If you look at this point, there are about 2 or 3 glass materials stacked one on top of the other. So avoid that and it will fix that problem. Avoid stacking translucency wherever possible. As much as possible, avoid it. What does translucency stack mean? What does it really mean? It means when materials like glass, smoke, fire, fog, when they overlap. So these materials, they are not opaque. For opaque materials, Unreal will just draw and move on. But for transparent materials, especially when they are stacked one on top of each other, Unreal cannot draw them once. So what it does is it tries to draw and draw till it gets to the end of the overlapped material, translucent material. Opaque object, the GPU will just draw the front and move up. For opaque object, the GPU will just do the overdraw for only the surface and move to the next one. But for transparent objects, the GPU must draw everything, even the ones behind it. And that's where overlapping causes a problem for the GPU. So transparency stack means multiple layers sitting on top of each other in the screen space. And so overdraw of the same, it redraws again and again, multiple times. That's what happens. That's what overdraw of the GPU does. When you have materials stacked one on top of each other, overdraw occurs when the same pixel is drawn again and again. For example, look at these fire particles. I'll just select one of them and focus on it. These are fire particles stacked. The GPU will want to carry out from the very first one to the last one at the end that overlaps. I'll go to the lit mode so you see. So you see these fire particles. The GPU will want to carry out overdraw on all of that. In games, players move quickly, and so the camera cuts. You may not have so much problem with these particles in games, but in virtual production, the camera lingers on a shot. And so frame after frame, for several minutes, a camera can be within a particular location, thus making the GPU to calculate the same translucency stack for a long time. This will result in glitches, stutters, and crashes in the middle of the take. A typical example in our day-to-day activity is when you're cleaning a window. You know, when you clean one glass, it's easy to clean just a glass. You just have a glass pane, you just click, it's fine. But when you have 5 panes stacked together, you see you need to keep on cleaning and cleaning and cleaning, and you ensure that you find a way to clean to the very end. That's the same way GPU calculates. That's the same way it calculates translucent stack. And so it results in glitches, giving it so much work to do. What is the fix for all of this? You control translucency. You don't have to remove it. We don't have to remove transparent materials or translucency, but you can control it. You don't remove it. 1, to avoid overlapping transparent, materials or assets that you have transparent, that have translucency. As much as possible, avoid them overlapping. Reduce particle count. Use masked material. You can mask material. Instead of using a translucent material, you can mask it as much as possible. Then you can use emissive material. Emissive material and opaque material will always give you a good job instead of using a transparent glass. And so we see that transparency is beautiful, but stacking it is one of the fastest ways to kill performance. Stacking glasses kill performance a lot. The other one that can also cause overdraw, that can increase overdraw, is dense meshes. We'll also look at that quickly. I'll look for any mesh here that looks a dense mesh. I'm going to focus on that and let's see. Let's take this example. Dense meshes can increase overdraw. I'll just go to the, let's see this. Okay, I'll go to the wireframe mode of this and let's see. Edit this. Let's open this object up. I think that's taking a minute. Okay, good. I open this up. Even from the triangle count, I can see that this is very dense. It's about 900,000 plus triangles. So I go to wireframe mode. That's another way to tell if this is. If the color of a mesh or an asset is solid in wireframe mode, then you know that it is dense and it's a problem. This should never happen in any real-time scene. Your mesh, your asset should never be this. You shouldn't have a solid color like this. This shows that this asset, this actor is very dense. And if you look at the count here, the triangles is a lot. Now I'm going to open up another asset of the same type, but with lower triangles count. I'm going to browse to assets. Okay, this is where this is, but I need the other one that has, which of these? I'll just do this. Okay, low poly. I'm going to open this up. I'll open up this. Taking a second, it's going to open up just now. Yes, we have this. Now let's go to the lit mode wireframe. Oh, look at that. You can see, you're beginning to see triangle. This is not a solid color. If you have this kind of, in your wireframe mode, if your asset is like this, you don't have a problem. Look at that. Look at this. This is solid color. Let's look at the triangles count, about 900,000. Then this is about just 1,160, You see the difference? But if we go to lit mode, let's put the two of them in lit mode and see how they look. You see, they look exactly the same way. But behind scene, they are not the same in terms of density. One is very dense, while the other is very light. Look at this. The same look, the same asset, the same actor, everything, except that when you go to the wireframe mode, the truth will be revealed. And when you look at the triangles count, you see that. So this is real-time optimization in action. If I have this on my scene, the only fix for this is just to replace. Just replace, change it. I have a dense one with over 900,000 triangles count. Why am I using this? Why do I need this on my scene? You just take that out and replace it with a less dense mesh. Next, quickly, because of our time, we'll go into LODs. Let's talk quickly about LODs. Okay, LOD means level of detail. Far objects don't need the same detail as close ones. So as objects get smaller on the screen, they should get cheaper to render. If this is not the case, then we have a problem. Back to my project. Okay, I'm back to the project, and we are going to look at this. Also, we are seeing that in the wireframe mode, this is a solid color because it is dense. It's not LD. Let's pick another asset here, another actor here. Let's select this. We'll be using this to talk about level of details. I'll focus on this. Let's open this asset. Let's edit it, open it in the editor mode. Okay, that will take a minute to open up. Yes, this is it. Currently, it has level of detail is 0. The screen size is 0.9. And the triangles, this is about 7,000 triangles. Before I change the details, let's look at this. I'll just click this. Okay, I have this. Okay, I think this is already using LOD. I'm going to move quickly to check. Okay, no, I need an asset that is not using LOD. I'll go pick up another one. Maybe this one. So I show you how to do this. Browse to this. Okay. Okay, well, I'll just pick up this, scroll to the LOD settings. I'll just close this. I seriously need to use something else to explain. Okay, edit this. Okay, I think all of these ones have, but I'll just show you how to. In the details panel here, you go to LOD group. We'll scroll down to LOD group. This is already high detail. You see that? I'll check out for this LOD group, scroll down to the LOD group. I'll just type this in, LOD group. Okay, so this has none. Yes, I need to explain with this kind. Level of detail there is none. I'm going to select and say high detail. Just before here, I'm going to look at this and say, you see, it only has LOD 0, which is high detail. I'm going to change this to high detail and give it, yes, I'll say yes. It's going to convert this very quickly. I hope this doesn't take forever. Let me stop sharing so this works very fast. And let me also stop my camera so that this can convert quickly to level, convert it quickly. Okay, I'll share my screen if this is taking that much time. And I'll turn on my camera. Yep. Okay, so while the LOD is still trying to come up, this is what I want to do. I want to skip to size maps. I'll take this slide here to size maps quickly before that conversion is over. What is size map? Size maps give a visual breakdown of how much memory each asset on our level uses. Example is your actors on your screen, skeletal mesh, and the rest. I'll open this other project. Since that Unreal Engine is still taking some time, I'll open this project and explain size maps that's working on textures, how to reduce that. You can actually check size map on any asset on your screen. In Unreal Engine, you can check the size map of on any asset. All you need to do is locate it, right click on it, and scroll down. You see size map. Now, for this particular one, you have 16.2 MB. And if we look at the next row, we realize that skeletal mesh SNK is taking up 14.9 MB. And this also shows here, you see that these textures are taking, this is what is happening. This is 5.6, this is 2.8, 2.8. Now, let's open up the textures and see what happened. The textures for this. So I'll locate the textures for this. Materials, and these are the textures for that particular asset. And I'll open them up. If you look to the top right, you see 2048 by 2048. That's huge. That's 4K. How do we reduce this? What's happening? I'll type in compression. So before we do this, please note, let's note what we had before. We can take a screenshot of this, or I can write it down. The normal map is 5.6, ambient occlusion 2.8, and we have this 2.8, and then we have 2.8. Good. So we can check back to know what happened. We can open the 4 of them. Let's open all 4. So we'll work on them. This is emissive, and this one is normal map. This is diffusion, and this is ambient occlusion. Okay, starting with this, let's optimize this. Type in compression. Let's compress this. Maximum texture size. Let's convert. Let's change it to 1024 and save. Next one, the emissive color. We have some colors here. I'm going to type compression as well. But first, we have to check. This is also a 4K texture. This is, except we're going very close to an asset, we don't need 4K textures. And most times, when you reduce this to it's 1024, you find that there is no difference in terms of visual quality. But in terms of memory, it reduces it to half of it. So I'm going to save this as well. And that for this 2048 as well, I'll type in compression. You can actually scroll down to get that, but a very quick way of doing that is for me to type this in instead of scrolling all the way down. Then that will be 1024. And I'll save it. Next, we have this. Compression is going to go.
Mfon, can I ask
I'll
a
change it to
question?
1024.
So,
What happened to this? What did I use? Okay, I'll save them all. Make sure to save them all. Okay, now I'll come back here, close this, and open it again. Please.
yes. So when we compress the texture size, whether virtual texture or a normal texture, so like you showed from 4K, we are bringing it down to 1K. So is this also reversible? Or once we reduce it,
Yes.
the size of the texture goes down?
It is reversible, and I'm going to show you just a minute.
Thank you.
Thank you. Yes. So I right-click on this, scroll down to size map. Let's see. Ooh, that's a huge one. I think we had 16. Look at the total size now, 5.8. And this is 1024. We can further reduce it to 512. But please note that while reducing, let it be to a power of 2. Always make your reduction to a power of 2, like 256, 512, 1024, 2048 is always in a power of 2. You see, often reducing textures from 2048 to 1024 gives you almost the same visual quality, but reduces, it cuts the memory in half. We have just seen that now. The memory has even gone below half of it. And that's a huge way to optimize your assets in your level and in your scene. For objects far away from the camera, this is a huge win. I don't need to see it so close. So why not optimize it? Why not reduce this texture? Why not compress it? Why do I need to have 4K textures for a distant object, when I can actually reduce it and look at it from afar. Now, I had to take this because this other one, okay, I think it's done. Pardon me to go back to this project. If we have the time, we'll still come back to size maps. It's a very interesting one. I'm going to, okay, let me show you that to, just like Jesse mentioned, we can take this back to compression. I can either it's this, just this, reset the property. As soon as you do that, look at resolution changes back to 2048 by 2048. We'll do this for all of them. Just hit this key, just hit, or you type in 0 and you're good. I'm going to just do that to this, and do that to this. When you go back to check the size map, it increases. So these things are very, sometimes one may not even, they are negligible, but they are easy fix. Very important. So I'll go back to my other project. Now, Unreal has converted this. If I now look at this, remember we only had the auto and LOD 0. Now we have a whole lot of level of details from 0 to 1 to 2 to 3 to 4 to 5. Let's see how it goes. Let's see how it works. Let's see how this works. Now, as I move away from this camera, I want you to observe several things. Observe, I'm looking for, it's not showing up here, so that's where we'll use. Okay, for this tree, just observe this level of detail and the screen size. As I pull away from that, please keep on watching. As I move further away from this mesh, just observe what happens. Now it's 0.0, 0.15, 0.0. As soon as you get to 0.1, look at that. As soon as you get close to 0.1, the level of details change to 1. If I keep moving further away, the level of detail will increase, giving us fewer triangles. But we didn't look at the triangles count. We'll see that just now. Now, as soon as we get to 0.05, it changes to level of detail 2. I don't want to go further. But at level of detail 2, how many triangles do we have? 1,812. Performance. As when we get to 1, how many triangles do we have? Count? 3,626. And when we get to level of LOD 0, which is the high detail, you get 7,251 triangles. So this is optimized. If this asset on my scene, as I move away, as the camera moves away, the triangles count reduces. So this is a very important feature, level of details, as much as possible, because sometimes you have the same actors, similar actors using the same mesh, scattered everywhere on your scene. What do? Reduce the level of details. As the camera moves further away, you don't, the player or the person looking at the scene, the cinematic, does not need the details when it's far away. What do we need? To disable it. We reduce it, reduce the level of detail. The other thing I want to show you is this. Let's look at this very closely. And I'm going to select 0. Let's see how it is when it's here. So look at it. Look at the quality of this foliage. Let's focus on the quality. This is this. And when we look at, let me just jump straight to 2. Look at that, 2. Triangles reduce. And let's take it all the way to 5 or 4. Let's use 4. Look at that. So when you're far away from this asset, this is how it looks. But you won't know because it's far away. But it is helping the engine performance, as we have seen. The other one is we can actually control this. We can leave it as auto. This is fine. If you leave it as auto, by going to the LOD picker. Okay, the LOD picker says auto. Now we have it auto. If I want to control this transition, what do? I'm going to enable custom. As soon as I enable custom, you see I can I can work on all of this. I can control all of this. 0, 1, 2, and then let's go to the very first one. This is level of detail, LOD 0. This is what you have. You can control this. This is level of detail 1. You can control this as well. So when this is 0.1, I can say, okay, at screen size 0.1, please make it LOD 1. At screen size 0.2, this is LOD 2. When it is 0.05, please change the level of details to 2. And so we have that. This is optimized. This is good. We can control that. We move very quickly to the next subtopic that we have to talk about. And I think the time is running, so we have to look at the next one, which is
You're doing great on timing. You're doing great on timing. If you go slightly over, it's perfectly fine.
Okay, thank you. Yes, after your level of details, in virtual production, we have several assets in their hundreds on our scene. How do we control the features? Do I go from one asset to another, changing the level of details? That's going to be cumbersome. That's going to be so much for us. And because virtual production scenes are large, you don't optimize one asset at a time. It's going to be tedious for us. We're going to use this optimization tool called bulk editing assets. Bulk editing assets is a feature that helps us optimize assets in their groups, So back to my project. How do I do this? In the content browser, I'll just select, let me use also, just to note that the bulk edit asset tools, or the property match metrics as it is called formally, you can use this tool for textures, materials, and skeletal meshes, and several others, different types of meshes. But please note that when you want to do bulk edit assets, you must select assets or actors of the same type. Note, you must select actors of the same type. So I'm going to pick, this is a texture, this is a texture, this is a texture. I'll right click on it and, okay, I'll just dock this in layout. Let me dock this properly. Okay. And I have textures. Okay, there you go. I'll just pick the first 3. I'll right click on that. You see asset action, and you see edit selection in property metrics. Edit selection in property metrics. I'll select that. Yes, now we have this. You see the several adjustments we can make in this, textures, compression, and all of that. I'll just go to level of details since that's what brought us here. Now look at the LOD bias. I can change this from 0 to 1. And now you type in 1, and then you see this pin, you just press on it. Once that is done, you see, look at that. On top here, you see all of these have been converted to LO, level of detail 1. Let's confirm that. How do I confirm that? I'll hover over each of those textures and see, look at that. Just look, you see LOD bias. I don't want to move my cursor because it's going to go. You see LOD bias is now 1. Please take note. Then you also just over it. That's all you need to do. Over it and leave your mouse. You see LOD bias is 1. The same thing with this. LOD bias is 1. Now, back to this place. We have now fixed the depth. So this can help you when you have a lot of actors or assets on your scene. You can change it back by just simply typing in 0 back. And you see everything has changed. It changes back to 0 in real time. And then I go back to my level still to confirm, for confirmation. So you see level of detail, LOD bias has changed to 0 for the 3 of them. This is real time optimization. You see it as it goes. We are testing it, and we are applying it, and we are testing it straight. So how do we do bulk edit via property matrix? Select multiple meshes. Right-click on them in the content browser, asset actions, and select bulk edit via property matrix. And then you apply the LOD group, and you're good. You watch as all the assets on your scene will be updated. So you can use this for virtual production scenes where you have hundreds and hundreds of assets of the same type. Remember that the assets must be of the same type. So LODs protect performance when the camera pulls back. We have seen that using this asset, the foliage. As the camera pulls back, if you have applied LOD performance as a performance tool, you will see in real time the LOD details will drop. You saw how it dropped from 7,000 triangle to about 1,000 triangle. That's a very good one. Next, we're going to look at draw call. A draw call is an instruction telling the GPU what to draw. More materials, more draw calls. A day-to-day analogy we can use to explain this is when you are copying a file in your computer, one big file of 1 gig, it probably will take you a few minutes to copy and all of that. But if you want to copy smaller files, maybe 1,000 or several of them, it will take more time. This is the same thing that happens, it's the same idea happens in your GPU. You have several materials to draw, more draw calls. So what do we do? What is the fix for this? Now, let's move to the project we're using. Let's check our draw call count, even before we start. Let's check our draw call count. If you can remember, the console command for this is start RHI. I'm going to go to full screen mode so I can see that. So look at that. The draw primitive call, that's the draw call count, is about 800 now. 700, it's going between 600, 700, 800. You can take note of that. And then I can take that out of my screen now that I know I've gotten what I want. So the benchmark is this. If the draw call count is less than 1,000, that's okay, that's good, that's not bad. If you have between 3,000 to 4,000, it's still okay. It's probably acceptable. If you have 5,000, that's danger. From 5,000 to 6,000 counts is danger. It's a lot of work for the system. If a mesh has one material applied to it, that's one draw call. If just one mesh has 3 materials applied to it, that's 3 draw calls. So an easy fix for this would be to merge actors. I'm going to just go to my content browser and use any static mesh to explain the static mesh to explain what the statement I just made. I'll
That's a very
select this.
good point you made there, Mfon, about the draw calls, for a mesh to have one material or three materials. So when productions are working with artists, this is something the artists need to understand. It's not only about, oh, my client gave me a brief, they want a statue of a statue, and I'm going to take it into Substance Painter and do all this. But are you creating a single optimized material, or are you making 10 or 15 materials?
I'm
Oh, but
telling you.
my mesh is optimized. Well, it's not only the mesh, it is also the materials, the material texture sizes, and the fact that, let's say, if it was, you have the statue of the dwarf, right? Or so if you have like a palace and you had 10 statues on either side, now that is three materials per statue times 10, and then the overlap, which is compounding, you know.
That's
So,
trouble.
yeah, big trouble.
And you see, sometimes we have assets that will have a lot of material. Just one asset having a lot of materials in it, not optimized. That's going to cause a serious overall towards the end of our project. Now, for this static mesh, I opened randomly from the content browser. Look to the details panel. It is made up of 3 materials. That means 3 draw calls. Now, back to my world. How do we do this in real time? Okay, I'm going to use what we have here. How do we optimize this? Now I have this. I'll just duplicate a few of it so I can, each of these assets now has a draw call each. This is another one. I hold down Alt to do that, to just bring it out. Now, I can merge these 4 actors to use just one material, so we can have one draw call instead of 4 draw calls. Don't forget that each of the assets, let's check on the content browser, on the details panel, sorry. I'll scroll, I'll just pull this up so I can see. I want to see how many materials this is made up of. Okay, this actor has 1 mesh, 1 material. 1 mesh, 1 material. So I'll just select 1, 2, 3, 4. I'll go to the tools menu, merge actors. Now, I've selected 4, you have them here, 4 selected. Please check this, replace source actor. So the moment I check this, it's going to merge this into 1 actor and replace what I have on the screen, on the level. I'll just hit merge actors. Give it a moment, and it tells me to name that. I'm going to say merge 4. I think I should say 4 because I have them 4. The other thing I want to do is I want to create a folder to bring them in. I'll right click and say new folder. I'll just call this merge because I want to place it in that folder. So I place this in the folder and I say save. Yes, I said save. So it's going to take a while, and maybe I should stop sharing screen so this can be fast as we have.
One more question, Mfon, that I find a lot of times during production people are asking, and that is same based on, oh, it has multiple materials when they're trying to do the optimization. So those multiple materials, can they be merged together as a single material inside Unreal Engine, or do they need to be done in a DCC program like Maya, 3ds Max, or Blender, or even where they are doing the Substance Painter for the materials?
Good news. Good news is Unreal Engine, when you right click and say merge actors, it has option for you to have similar, you will merge the actor into one and you can have 3 materials. And you can also merge all the actors into one and one material. When you look at these assets on the level, they look the same. When this one is done, we're going to see, you see the actors look the same asset, but it now has only one draw call for those of them merged. Even though ideally what is done is if you have foliage, you just select all the foliage or all the rocks on your level and merge them. One draw call, one material, the same material. So good enough, Unreal Engine can undo that.
Yeah, that's great news. Only one caveat: only merge the actors when your scene is final and it is production ready, because you would have placed the rocks or trees or any other objects in special locations, and you know that you are not going to edit it anymore. That's when you want to merge all these actors into a single actor.
Yes.
That way, it is then not editable, because all, let's say, 20 rocks are one actor then. Is that correct?
Yes, one actor then, and they are scattered in different places. So you don't have much problem. Now let's see this. Okay, this is done. Look at that now. This is now one. Let's see how it looks. Look at the scene. We see how the same. Now they have been merged into one. If you select one, any part, you see it's merged into one. Move it all around, and this is now one draw call, highly optimized. We can also do that to this. Let's move close and see this. Look at this statue. If I select this and okay, do I have my camera on? Okay, I'll just take that. So I just want to be sure. And in the details panel, this is selected. I'll just scroll to see. This dwarf statue is made up of one mesh and one material. I can merge it with, let's see this one. Let's see how it is. The horse statue made up of one mesh, 2 materials, meaning that this one has 2 draw calls. This one has 1 material, 1 draw call. We can actually shift select this and all the other smaller statues around here. And we can select this. If it has a base, I can select, okay, I can pick the base. This has a base, I can shift select this, 2, 3, 4, 5. I can do this. Now I move to tools and merge actors. This will take some time, but I don't want to. But I'll do it just because I want to show you. Now, we may not have time to go into all of this, but there are lots of details here you can play with. At your own time, please look at this. Look at this tab, and there are lots of settings here we can work with for the merge. I'm not going to merge because we already know the process now. In summary, for quad overdraw, we need to watch the mesh density and transparency. For any of these level of details, we need to reduce detail as distance increases. For draw calls, reduce materials. Merge wisely. Reduce materials, merge wisely. For instance, if you have repeating props on your level, like rocks, lamps, and others, you can merge them wherever possible. Merge as much as possible. And finally, we'll look at textures, optimizing textures. I already started by looking at size maps. That was the last thing, but I had to do it when Unreal was taking more time. Textures can consume both memory and disk space. which means that any optimizations we do on our texture, it can have double impact. It will have impact on the performance, and it will have impact on reducing our overall memory footprint and disk footprint. I want to start with virtual textures. I think we talked a bit about this, so I'll just run through it. I'll just speak about it. We don't need to practice it and go back to the end because I mentioned this. Textures impact both memory and disk space. I mentioned that. Streaming virtual textures. Traditionally, Unreal Engine uses MIP-based streaming. And so, for instance, even if a single pixel on a mesh is visible, the GPU will render the entire object, which is a lot of work. For example, on a mountain range at a distance, if only one pixel is visible, the whole mesh is processed. This is inefficient, especially in large, complex scenes. And so what streaming virtual texture does is solves this problem. If you enable streaming virtual textures, it will allow only a single pixel that is to be loaded. So streaming virtual textures allow single pixel loading instead of full mesh MIP streaming. Instead of the default, what Unreal Engine has by default to stream the entire asset. Streaming virtual texture solves this problem. So the GPU will only load what's actually visible, saving memory and improving performance. How do we enable that? You go to the project setting, and in the rendering section, like you have seen, you enable virtual texture support. And once that is done, in the content browser, you select your textures, right-click, and convert to virtual textures. How do I know a texture is using virtual texture? I'm going to show you just now. If you see any texture, in the bottom right, you see VT. It means this texture is using virtual textures. So now you know how to convert your texture to virtual texture. You know how to check if it is using virtual texture or not. The other one is the texture group. Very interesting one. We'll go to the engine to explain this further. I'll open up a texture here to explain texture group very quickly. I'll just type in, okay, I have one here. I'll open this up. I'll just open any one up. Now, good. What do they do, basically? What does the group texture, what does it do? Textures take a lot of memory. So Unreal provides texture groups to help us manage them efficiently. How? Texture groups help us to control filtering. It controls MIP mapping, it controls LOD bias, and others. So when I scroll down, okay, I'll just see it here. Look at the texture group. If you click this drop-down arrow, you see we have a whole lot of it here. We have dozens of textures, texture groups here. You see that? So you can select your texture and assign it to a texture group. So texture groups are defined in your project's configuration files, giving you full control on how, full control over your textures, over the textures in your project. Now, I'm going to just close all of this so that we can. That's basically all about virtual texture groups. So optimizing textures isn't just about memory. It directly affects GPU efficiency, streaming performance, and the project size. So virtual textures and texture groups will help you have faster, smoother, and more scalable real-time projects. We have talked about sitemaps. I said size maps is a visual breakdown of how much memory each asset uses. We saw practically how to do this. Textures are the biggest contributors to memory usage. You can adjust a texture's maximum size in your compression section. Remember to always do it in a power of 2. Always use powers of 2, 256, 512, 1024, 2048. Often when you reduce from 2048 to 1024, it will give you the same visual quality, but it will cut the memory in half. So always check your textures. Check your assets, identify 4K textures, compress, and check again. Size map helps you identify which textures are heavy and which ones are not. Tips and tricks. We'll take some tips and tricks before we go. For camera and scene, only render objects visible to the camera. Skip everything else. For lighting and rendering, bake static lighting and limit expensive real-time effects. To optimize 3D assets, use LODs. Merge meshes. Merge as much as possible. Merge wisely and reduce polygons. For textures and materials, compress textures, simplify shaders. And for performance monitoring, always profile your GPU and CPU and maintain steady frame rates. In conclusion, use size maps to identify heavy textures. Resize, compress, repack textures. Enable LODs for meshes and use Nanite if possible. I forgot to say to use Nanite, you mostly have to go to your control content browser, right-click on the asset and use Nanite. Check shader complexity and draw calls. Profile your scene using start units and start GPU. Thank you very much for joining this section, and I hope you practice everything and start optimizing your scene as soon as possible.
All right, Mfon, you want to switch on your camera, please?
I never knew my camera was off. While I was trying, I just came back to the screen to see that the camera was off, and I.
First of all, that was amazing, and I can certainly say it was a wonderful session because it helped me again relearn some of the tips and tricks that I had taken for granted. And this is something so important in the industry right now. People have 5, 10, 15 years experience in Unreal Engine, but we take these things for granted. And then in the middle of our game release or maybe production is going live, this is when it all comes together as a bottleneck. And what you've showed today is a timely reminder, especially with Unreal Engine 5.6 and now 5.7, things are getting better. But just because we have Nanite or Megalite or other stuff doesn't mean that by clicking those buttons, everything gets optimized. You still have to do the manual work. You have to plan it and design it for what the purpose is. I mean, that was just fantastic, and I will definitely be using these tips and tricks again with my candidates as well for the graduate programs, and making sure that those who are going in the industry do it right.
Yes, they do it right.
Thank you. That was really very good, very clarifying, all nicely put together in one place, in one spot. So yeah, absolutely. Something that is maybe not so interesting, but something that is so needed for every project.
Important.
So yeah, thank you so much for sharing all this with us.
You're welcome. Thank you.
Much appreciated.
Absolutely. And for everyone else who will be watching this in future, it will be available on Virtual Production Dojo as a pre-recording session, as well as the project file that Mfon shared and was showcasing throughout the entire demonstration will also be available for you to download. So please be creative, keep working, and remember, you can always reach out to us at Virtual Production Dojo, as well as please connect with Mfon on LinkedIn. She is an amazing artist, a great teacher, as you have seen today. So, and look ahead for some new interesting trainings that Mfon will be running with Virtual Production Dojo. So with that, thank you again, Mfon. It's been amazing to have you on inside the dojo, and have a wonderful evening.
Thank you so
everyone.
much for having me. Thank you for having me. Bye-bye.